Okay. Hey, everybody, we'll get started in just 2 minutes. All right, we'll get started. Can everybody hear me? I think my mic is working at this point.
We can hear you.
Yes,
All
sir.
right. Good, thank you. Better than last time. I tried to send out the link to the representation of adding schedule to a 3D BIM model. Look at that.
Yeah.
Jack, I just lost you.
You mean the video, Pat?
Yeah, sorry.
Yeah.
Did I say
Yeah.
something else?
Thanks. Well, okay. Yes.
So you were able to watch that then?
Yeah, it was really short. It was like 2 minutes, right?
Yeah,
Okay.
and it's just you know, as you build, and Susan, you're taking Revit right now. So as you build your model, as you complete your model, you add in durations and like sequence to, you know, different components of the building. And it's just you know, it's kind of a cool visual representation of, like, you know, paper schedule that we're making. It kind of makes it look a little more, you know, understandable in some ways. And additionally onto that, you know, I'll find this link for you guys. There's a visual software, again, to add to your Revit model. And it will identify the things that are different from, or something that looks like it's not matching the Revit model. So if they put a piece of ductwork where it's not expected, it'll highlight it as a potential problem. I talked a little bit about that last time, but it's, you know, it's kind of the future of the industry, trying to take out the opportunities for human error, or, you know, just mistakes and missed things in the. So it's just altogether, it's kind of the automation of the industry is where it's all going to. And I know, you know, we have different people here in different parts of their education in the construction technology field. One of the, you know, probably the biggest, you know, the most revolutionary, the biggest thing that's come around in the industry in the last, you know, probably started 20 years ago, started getting used a lot, maybe 10 years ago. It's called, you know, they use a lot of different terms for it. Some people say Revit, some people say BIM, some people say VDC, building information modeling. BIM is kind of the basis of it. And basically you're putting in, instead of drawing your project or your design in 2 dimensions for a piece of paper, you actually build it in 3 dimensions. And it's not just you know, it's not a geometry, just it's not just adding the extra layer of geometry. You can assign building material properties, characteristics, You can do an energy model to see how much heating and cooling based on, your wall thicknesses, your insulation values, how much sun will come in from, whatever direction your window is facing. It's getting more and more detailed. Originally it was just, it was more of a geometrical model at first, but now it's taking on more and more characteristics, more and more lifelike. And a lot of projects now, they'll do, if it's a ground up, a new project especially, they'll do what's called BIM coordination. And that means each contractor inputs, so there's a design that's done in 3D, and then the contractors will, look at that design and actually build in every fitting, hanger, pipe into the design, and it'll be checked by each of the different disciplines, and it'll be signed off by all the disciplines to agree, yes, we've coordinated all the different trades. You got mechanical, HVAC, plumbing, electrical, all that stuff gets added into the same model. And if there's any points where there's a clash, you do what's called clash detection. And if there's some place where a pipe is going through a ductwork, it'll be outlined. And the BIM coordinator for the project will have either the plumbing contractor or the heating contractor would have to move the ductwork or move the pipe so it's not clashing anymore. And if you do a BIM coordinated project, if you're working on a BIM coordinated project, the amount of time and savings there is, that's pretty much what a construction project is just communicating the design and then trying to coordinate between all the contractors how to get that design built in, real space. Before, the tool was a 2D piece of paper you looked at to try to coordinate all this. Now, when you're doing it in 3D, you can go from an average project might have, depending on size, it might have 200 clashes. You might get through a project that's BIM coordinated with 3 clashes, 3 times when, something had to be moved or relocated. And it's incredible. Also, the other part of that that's really interesting is now you lay out, you don't have 2 guys up on ladders laying out where the penetrations are, where the hangers, need to go into the ceiling. Now you have a robotic laser that will shoot a laser point at where the penetration is or where the hanger will go up into the ceiling. And instead of 2 guys on ladders, running around with tapes, 2 plumbers trying to measure, how far off that wall the piping is, now you input that 3D BIM model and you overlay that software for the robotic station, and the thing will just, it's like magic. It'll just turn around pointing, and it locates itself with a couple control points, and then from there you have a little iPad looking interface, and you just go point to point and say, for this hanger, shoot the points where the hanger is to be, where the anchor is to go into the ceiling. This robotic station will just move, shoot a laser, and guy just presses, spray paints a little dot at that point. He knows, the guys know to come put a hanger in the ceiling right there, or the guys know to core a hole or set a sleeve for a penetration. Even beyond that is, I'll send these 2 links to you too. There's a Hilti robot that actually goes and not only marks the location, it'll actually drill and insert the hanger. The automation keeps moving farther and farther along. It's really incredible stuff, and it's where, unfortunately, the labor part of construction, which provides so much opportunity and great jobs, is the most expensive part in most cases, and automation is aiming to reduce that. There's unfortunate parts to that, but there's also fortunate parts, lowering the cost theoretically of housing and buildings. If it costs less to build, it might cost less to rent, all that kind of thing. So it's really interesting stuff. Revit integrate with Trimble? Yes. Susan just asked a question. Does Revit integrate with Trimble? Yes, Susan. I actually did that on a couple projects. You take the Revit model, and it's a lot more detailed. You need a really detailed model. You can't take the architect and engineer's drawing. It's almost, or model, it's almost garbage. Honestly, most contractors start completely from scratch because there's so many mistakes in the engineering model, which is funny. And the contractor will build, you know, a really detailed model that shows every hanger, every flange, every coupling. And once you have that model built, you use there's a Trimble software overlay onto Revit that allows you to upload the points into the Trimble robotic station. It's really cool stuff. It's almost like magic watching it. You know, a lot of people who've been in construction have been out in the field for 20 years, kind of roughly doing the same thing, and all of a sudden this kind of stuff comes along, and you know, it's almost scary at times when you see it. You're like, wow, I can't believe it. And that's how it'll go. They'll automate tasks. You know, you think of a robot, you think of like a humanoid looking thing doing the same thing as a man will do. That's wrong. They'll automate each little part of the task, not the whole task. And they'll have a little different robot. This robot drills the anchor in. This other robot comes in and screws the you know, the threaded rod down and cuts it at a certain point. They'll just have different little machines coming in and doing each little task, and you know, eventually, and all of those tasks will depend on a 3D model of the design being, you know, created and, you know, detailed enough to work with. So not trying to get too far off topic, but it's just, it's a part of the industry that is out there right now, and it's, you know, progressing really quickly. I worked for a company in 2005, and we had Revit, and I thought, wow, that guy was really, you know, ahead of his time. He was a really forward thinker. We had Revit instead of AutoCAD because AutoCAD was more expensive at that time, and Revit was a new company, and it was cheaper to buy Revit than it was for AutoCAD. It wasn't because he was some genius who wanted 3D, you know, capabilities. But so that was like 2005. Architects liked it at first. It was faster for them, but contractors, you know, had no use for it because there was no savings until they did a project and realized how much savings there could be in coordination. And you know, they could save 20% and then tell the customer they saved 10% and say how lucky they were, and you know, increase their profits. So it's really interesting software, and if you're going to be in the construction industry, I highly recommend getting familiar with these kinds of software. They will be the, you know, only thing around. It's you know, before there was there's only really one major software in 2D. It wasn't one major. There's a bunch of softwares. There was one dominant one, AutoCAD. There was also MicroStation and AutoCAD Lite and Chief Architect. In 3D, it's pretty much just Revit. There's AutoCAD 3D, but doesn't have the capabilities. That's kind of just the geometric thing. So if you do have a chance, and you know, you're looking at your courses for your time at Triton, Revit is a really good class to take. It's a hard thing, especially for people who used AutoCAD. I think it's even worse. But I've read articles such that say younger people who have been playing video game first-person shooters for a long time are kind of more natural at it. Like Susan plays a ton of first-person shooters, right?
Yeah, this class is such an interruption. I don't have time for that.
I know, right? I know. Call of Duty is your thing, right?
Right.
So, but it's just interesting stuff. So that is my spiel. And any questions or anything from last week? We kind of went through the first two chapters. They're very short, actually. There's not a lot of information in them. Basically, it's just kind of an introduction to scheduling and planning, and you know, why we do it, how we do it. They introduced chapter 2 is kind of bar charts, introduced the Gantt bar charts, the different types of information that you can put on them, but they're pretty simple in reality. I think there was talk of the critical path method somewhere where I think we get farther into it, but just following the sequence of events that has to happen in a certain order, and which will define the critical path, will define the, the shortest your project can be. If you have other things that, you can do before or after, that's fine, but there's a critical path, meaning, it tells you if your critical path is 60 days, you cannot finish faster theoretically than 60 days unless you change the duration of some of the tasks within the critical path. So the next chapter 3 is a little more nuts and bolts. It is networks. So sorry, I jumped ahead. I know I asked. Did anyone have any questions on the first 2 chapters, or any of the questions or anything like that?
Nope.
So homework 1 and 2 is due Monday?
Yeah. So 1 and 2, if you can get those in, you should be good. I didn't have that. I didn't have it visible. So I think I have 1, 2, and 3 up there now. I hope if you don't see 2 and 3 up there, let me know. And I do want to, like, just logistically, we'll try to submit through Blackboard, they're in the homework submission, just to try to keep it all in one spot.
Okay.
But I know these are a little much more kind of question and answer kind of things. There's not so much like multiple choice or anything like that. So if you have any questions, by all means, let me know. Shoot me a text if you want something fast, because I'll see that first before we see an email. So, all right. So from there, we'll get back into chapter 3. We'll go through some of the network stuff. It's a bit dry, I would say, but it does have some good information, and the scheduling is it's kind of a hard science to define, because there's just a lot of logic and precedence and all this kind of thing happening. I mean, when you are a construction schedule, I think it's a little more simple, or it's just more intuitive to be able to, instead of thinking of nodes and A's and B's, to actually think of a task and thinking of, I mean, it's easier for me to think of, okay, so we have to bring in the excavator to do that task, and once the excavator's done, the site utility guy comes in, puts down that pipe, excavator comes back in to backfill it. When they're tasks, it's a little more concrete for me than when, some of this explanations in the book are a little bit, just kind of a lot of A, B kind of stuff. And there's a lot of information there. The examples from the book are pretty good. I think they're pretty well explained in the examples, but it does kind of all blend together after a certain amount of reading. But we will go through it, and we won't spend a ton of time. If you look on the syllabus, I think we have a quiz in 2 or 3 classes. I'll send out a study guide for that at our next class. And I think, let me look at the syllabus real quick just to confirm the date. I'll send out like I said, a study guide that will, just kind of show you the format of the questions and the, kind of questions we'll be asking, that kind of thing. I'll send it out through email, and I'll post it on the site. Yeah. Quiz is on the 5th class, so that would be a week from today. Yes? No, 2 weeks from today. Week 5, sorry. Quiz 1 is 2/15, sorry. So next couple classes, by Wednesday of next week, I'll have a study guide out, and you guys can, take a look at it. Just a quick reminder of the dates that matter for your classes, in terms of if you want to drop a class and still get your money back, all that kind of stuff. 100% refund is on 1/31 this Sunday, I believe, and then a 50% refund is a week from today. So just pointing those out in case anybody has any reason that they want to drop the class and not maybe get your money back. That would be probably ideal. So, all right. Has anyone ever had any like formal scheduling where you had to make a charts and graph or whatever for a project?
Yeah, I use Microsoft Project.
Okay.
Yeah.
And what is your job that you make those?
I'm a superintendent, so I do like smaller schedules. So I'll do like updated 3-week schedules, stuff like that. So
Yeah. Like, gotcha. So the 3-week look ahead kind of stuff?
yep, exactly.
Okay. And is it, you use project, so you're not like loading resources and all that stuff. It's just kind of the bar graphs showing, what activities are happening when?
Yeah, exactly.
Okay. Any tips or anything that you run into when scheduling? Like, what's your biggest challenges besides, finding out what guys are doing and stuff?
Kind of. I mean, I've just recently started doing this, but
Yeah.
just communication basically that's key. Is
Yeah.
talking to people. You don't want to be putting something on there that you don't
Right.
that you're not confident in. That's going to be done in that time.
Yeah.
So rather
Yeah.
overshoot time frames than undershoot them.
Exactly. Yeah. And that's the thing, when you turn in a schedule, it matters to certain people for different reasons. When you're working, if you don't mind me asking, what kind of location facilities are you working on? Like schools, hospitals, houses?
Yeah, so this is my second project now. I was at a CPS school in the summer, and now I'm at UIC. So
Gotcha.
it probably would be a lot more difficult and matter a lot more of kids that were in the building. But
Right.
yeah, so
Gotcha. Right. And that's an especially, tricky part of scheduling when you have, you're working in a building that's occupied, and, if you take too long, you might be taking away a funding from, or a cash flow from a place. Your schedule affects a lot of people. And your schedule is dependent on your communication with, however many different subcontractors. So it's real easy to miss something or have something change, and maybe my carpenter didn't mention to me that his foreman was going on vacation, and now his crew moves slower and stuff takes longer. And like you're saying, it's communication is all you can do. You cannot control everybody. You cannot predict everything, exactly. The best thing you can do is try to over communicate and document, what you're talking about. It's, schedule can obviously kill a project, liquidated, if there's liquidated damages. Sometimes liquidated damages are a serious number. There can be into the thousands of dollars per day for every day you don't turn, the project over on time. So, that was another good point, is you do want to try to make sure you give yourself some fluff. Stuff takes longer. Unforeseen conditions arise that, it's part of the job. It's part of the industry. But all you can do is communicate your best, and take reasonable precautions against under forecasting your time, that kind of thing. And letting the people who do the work put the onus on them to explain it. They're doing the work, so if you put it to them to help you fill out that information or come up with that information, you're going to be in better shape. Although sometimes then people will give you unrealistic time frame because they don't want to be rushed. So it's a balancing act there too. But yeah, usually on any construction project, you'll have an overall project schedule, and then kind of either weekly or bi-weekly or once a month. There'll be the superintendent will create 2-week look ahead, 3-week look ahead. That's a lot more detailed than the overall project schedule. You get too much detail on an overall schedule, and it gets more difficult to read. It's hard to print, and it's hard to fit on a piece of paper, especially if there's a lot of tasks and interactions and interdependencies. It gets pretty difficult to work with. So I will share. I have slides made up for this, but honestly, God, it's clear on the book pages. So I'm going to be going down the book because, like I said, these are kind of, not exactly lends itself to, description on a lot of these nodes and A to B and 10 to 20. So I will share that. It's easier for me at least to look at the book at the examples that we're talking about. All right. You guys see my screen then?
Yep.
Yes.
All right. Thank you. So networks, basic networks. So we're basically talking. So last week we talked about bar charts, Gantt charts. Pretty simple concept. There were some, little ticks to them. You can add different types of information where you'll have a bar chart overlaid with a completion percentage, and it's helpful sometimes to have that different overlay of information. You could have more breakdowns. You could have more precedence information, meaning task 1 has to be completed before task 2 can go, and task 3 has to be, all that kind of interdependency. One of the other ways to do that is with the node and arrow charts, they're called, and they're kind of in engineering, there are also we do this with P and ID diagrams. It's basically you're trying to visually represent the logic of a sequence of events. And that's kind of the basic network we're talking about here. Network, logical and chronological. So the logical part is kind of the addition. There's somewhat of that in the bar charts, but this is a little more representative in terms of the logic and the chronology between for a set of activities. This was also developed kind of pre-computers, so you can kind of see some of the logic trying to be captured on a whiteboard as compared to putting it into a computer. Basically, the network diagrams are just trying to show same thing, what the relationships, what the different tasks can sequence, duration, and as well the logic and the relation of one task to other tasks, that kind of thing. Two kinds of networks they described here were the arrow network and the what was it called? No, not node. Node is a part of arrow. Arrow and node networks. And I don't know that I've ever seen a schedule done in this way on a job site. It's pretty uniform that we do the line bar graphs, that kind of thing. But when you are trying to do logic, when you're trying to explain process and implementation, things like that, this is helpful for it. It helps you figure out scheduling sometimes. If you have a really complicated task, where it's not just one room where you're controlling all the contractors. Sometimes you'll have a building and there'll be different parts of this building, and we talked a little bit about sub projects and sub tasks. When you have really complicated things like that, this method of organization can help you know, sort things out and determine, you know, what interdependencies that are existing that, you know, maybe don't, you know, aren't obvious because they're not a first level interdependency. Maybe it's 2 or 3 levels down where you wouldn't necessarily think about it, but once, you know, 2 tasks go by, then the interactions kind of come back to each other, kind of thing. And you'll see, I know that's a kind of a weird, obtuse description, but we'll see that a little farther down in some of these examples. So in the arrow networks, basically, and there's different names for them, but arrow network is pretty much the clearest. You have your list of activities, and then you have your list of interdependencies, your preceding tasks that have to happen before one and after the other. You know, there's simple. The example 3.1 is kind of your simplest case. Not your totally simplest case. Your simplest case would be a straight line, but that's obviously doesn't need too much explanation. But in example 3.1, you can see a case where task A is, you know, a precedent for task B and task C. So they're trying to show that logically here and kind of show, you know, determine your paths. You're always looking for kind of critical path and interdependencies when you're doing these diagrams. That's what they're used for, to help you establish, you know, the logic and the programming sometimes when you go down, when you bring it to a computer level of how tasks interrelate. So that example 3.1 is fairly simple. You have task A. Task A has to happen, and task A, when task A finishes, both B and C can start. B and, you know, B goes to, has an extra interrelation with D. C does not. So it's a straight, that's kind of just a straight line of it. So you're just showing kind of 2 separate paths. When you get durations for activity A, B, C, and D, that's when you will be able to identify, okay, which one of these is the critical path. Does task C take longer than task B and D? That'll tell you when you get to that level. You can tell what your critical path is, and that's, they don't really talk about it here, but often you're trying to establish critical path timing. Obviously, that's what we're doing here, scheduling. Now we got, I think that one was simple enough, but it's just the sequence of the tasks. The numbers there, those aren't really durations. They're just kind of node identifiers. So it's the 10, the 20, the 30. Those are just identifiers. So you can, so the task is actually A, and A gets you from, you know, point 10 to point 20, and you're just providing the node numbers so you can describe those type of systems. And then when we get to a little bit more complicated network, on example 3.2. So in example 3.2, you have, you know, the obvious solution, if you're trying to do it, is the solution A. Well, then you realize solution A is incorrect because you have an extra step in there that, you know, you don't have that with the precedence. You got task A. Task A is a precedence for B and C, and then both B and C have to happen before D happens. So, you know, the first attempt to diagram a solution is solution A. The problem in that case, both B and C from the start, you don't have a unique identity at that point. That's why the solution A is not a proper solution, because when you're describing task B and task C, there's no difference. You're going from node 20 to node 30 in both cases, so that you can't There's no way to differentiate. So the way to solve that problem, they will often add in an additional step. It's called a dummy activity, just for no other reason than to be able to differentiate why B is now different than C. And there you see that dummy, they put it into B, that gives you an extra node. So you now have a path of 10, 20, 30, 40, 50, and you also have a separate unique path of 10, 20, 40, 50, two different paths. Similar, it could be similar durations. We don't know the durations here yet, but we know that we can at least differentiate between the two, when as you do the logic of it. Again, remember, this is all diagram logic. I know it's not necessarily the most exciting part of the topic, but it is helpful when you're as we get into scheduling more difficult activities. You do have to have a way to describe some of these things, and if you don't, you kind of get stuck, and you have information that is, it will lead you astray. You'll have, incorrect information when you do get down to the scheduling of the activities.
Hey, Pat.
Yeah.
I totally skipped these on that PMP exam because I don't get it at all. I mean, why is A not good?
Because
Solution.
so
Sorry.
yeah, so in solution A, you have the precedences right. So A happens, that has to happen before B and C. That's correct. And then you have the precedence for D is correct also. B and C have to happen before D, and in that diagram they both do. But how these are described in the logic flow of it. So when they're, you're putting it into a program or describing it in a logic, in terms of logic, there's no way to differentiate between path A, B, D, and path A, C, D. And it's just a logic. There has to be a way to differentiate in terms of logic. I know it seems like a lot of extra work for something that's not that helpful, but the network diagrams do become more complicated as we move in with more tasks, and you want to be able to tell the difference from getting to point X to Z one way and getting there another way.
Okay. All right. That helps.
I know it's not super clear, but it's what I got. So the way to differentiate, like I said, is to introduce something that allows you to differentiate between them. It allows you to show two different paths when you're describing it, and that's add the dummy task in. So in this case, the dummy task is represented between 30 and 40. That's small letter D task. That allows two different paths, 10, 20, 30, 40, 50, and 10, 20, 40, 50. And that said, so introducing that dummy task, you're trying to create two unique paths. That said, there's three or four different ways you can do that, which will be considered correct. You can put that 30 node down in the C task, and B could go straight to 40, and C would have to go to 30, and then dummy task D to 40, as kind of shown here. And the dummy task could also, the other way to do it, which would also be a valid route, would be to go straight to the dummy task out of task A instead of going straight to B or straight to C. That's what the diagrams here are. So you have three different types of solutions here, all the same reasoning and all theoretically are correct. The dashed line is the dummy task, and they're just showing that dummy task can be inserted in different path locations and still be, it still will cause it to be a unique route and between nodes, and will work for any of the four different. I think there's four. That one's not shown. Yeah, any of the four different options will work. It's just it's kind of a mathematical thing where you're add 8 to both sides. It still represents the same thing. It's kind of a similar logic here. When you're in algebra, I'm helping my kid with algebra all the time, and it's always those kind of things. Divide both sides. Add 8 to this side, add 8 to that side. It doesn't change the value. That's the same kind of thinking here. Just doing an operation to provide you a unique path doesn't change the value. So there's as we go through in chapter 3, they give more and more complex paths and solutions to those more complex situations. We're looking at 3 again, similar kind of description. You have different precedents. Again, you have A precedes A and B, and then we have a little bit different here with node E, which we didn't have before. So we've added a level of complexity, and now we're trying to look at all the different ways that can be identified. So we got A, B, C, D, E, and basically A before B and C, we know what that looks like, and then D before B, and B before D, and then B and C before E. So they kind of diagrammed out 3 different solutions here, just logically. And as we kind of look at this, it kind of, it's kind of a trial and error logic puzzle here that they're doing. And basically the first 2 iterations are, while at first glance it kind of looks like they got it, you realize, again, who can tell me why, in first glance, we're looking at that first diagram, the top diagram, why that would be incorrect? And actually, the first 2 diagrams would be incorrect for the same reason on the last one it was incorrect.
Because you can't differentiate between
Yep.
B,
Right.
top one, B and C, and then D and E. And
Yeah.
then, okay.
Yep. Right. You have all the same nodes again, and your paths. You might show different labels on your paths, like A, B, A, C. Those are different. You think you're talking about a different thing, but again, there's no way to differentiate because both B and C are still just going from 20 to 30. There's no way to differentiate between B and C in that case. Same thing with D and E. You're going from node 30 to node 40 again. No way to differentiate those 2. Then you go to the next one, same answer you got there. Basically, the top path, A, B, D, cannot be differentiated. There's no difference there because you're still just going to the same nodes. You just show different tasks, not necessarily a different path. You don't have that extra node that makes it different. Here, the arrows here are the actual task. That's the act of doing something. The nodes, or the circles with the numbers in them, are your kind of points, the states, I guess you would say, from state 10 to 20, from 8. You're just trying to differentiate your critical paths, and that's where we're going to. I know there's a lot of logic games going on here, but there is a reason for it as we get farther and farther down in complicated stuff. So we look at option, what do they call them? Figure C, option C. That actually does provide a a differentiated path by adding in, again, that dummy task. So now that dummy task allows a differentiated path from, you have different nodes, basically, an extra node where the dummy task, creates an additional logic point or logic task that creates a different path. So they're not exactly the same anymore. And we'll, on tests and quizzes, I'm not going to be looking to kill anybody on logic diagrams. I'm going to want you to understand the thought behind them, and not necessarily, I'm not going to be looking to trip anybody up on, logic diagrams and, dummy tasks. I want you to know the concept, not so much show me, how 4 dummy tasks can be used to, create an alternate critical path in case A, B, C, F, or something like that. So I know this, again, dry stuff, but it's just kind of necessary for these networks, the networked principle of a schedule and showing relations between all these tasks and points. Sorry. So I'll just kind of go through the rest of the examples, kind of point out a couple points through them. We don't need to go into them wildly. As you go through the homework for 3, maybe look at this homework a little early. We'll do one class exercise after this, but take a look at it, see if you have questions early on. So if you do have a question, I can try to help explain it. I know it's sometimes it's hard to explain. We're using, vocabulary we don't often use in construction or anything like that. Logic diagrams, that's not coming up too often at a construction meeting, but I will do my best to try to put it in words we can understand. Example 3, 4, the diagram gets a little bit more tricky, and basically, the point of all these dummy tasks and logic diagrams is to create the simplest network diagram with the least amount of additional steps, I'll say. So if you've got activity and precedence as shown in example 3, 4, your goal is to have no dummy task if you don't have to. When you realize that, yeah, I do need something to differentiate, you put in one dummy task and see if that takes care of the problem. If it still has a precedence problem and still, well, the path is still the same from X to Y, whatever, then you add dummy tasks as needed to try to create unique paths for all the options. So as you can see by, and we've added, I think we didn't have F before, right? We didn't have F before, so now we have additional activity F. Starts to get a little more complicated. They added 2 dummy tasks here, trying to differentiate between, ABD and ACF. Those 2 would be the same if we didn't have the dummy tasks 1 and 2, which, then create the different task for E. Just it gets, I know, a little bit obscure, and I just want you guys to kind of understand the concept behind it and be able to explain, unique paths and being able to identify between different paths for a construction project. Again, so, and as you can see, these the network diagrams, the more precedences there are. So, when you have a bunch of precedences, you can see on 3.6, now we're getting, more and more precedences for N3 tasks. it just starts getting more and more complicated of a network diagram. Look at good 3.7 has all kinds of dependencies and all kinds of tasks. We're up to M number of tasks and all those precedence relationships, and you start getting all kinds of crazy looking network diagrams there. This was more useful back in the day, so basically what they were trying to do when they were doing all these network diagrams and tasks and logic diagrams, computers weren't, especially used in construction. They would be used for logic and programming. This was their way to, mathematically compute what the critical path would be when you have a really complicated set of relationships and interdependencies and all that kind of stuff. This was a way for them to be able to, mathematically prove, okay, I have 50 different tasks and all kinds of different interdependencies. This logic diagram, this network diagram is the way they would use it to, figure out, okay, based on all these tasks and all these precedences, this is the critical path, this is the shortest path, the route to, to the end, and, the shortest path might represent, 27 days. And they weren't even concerned about the duration, they were just concerned about the path. Once they have the path, then they can assign whatever durations to those letters, E, F, J, all those things. At that point, you could throw the durations in there, and you found your critical paths. Redundancies, that's kind of like it sound. You're having, you have additional steps that are doing the same thing. It's not exactly wrong, but it is unnecessary. So you try not to have redundancy. Sometimes you can't logically. It can be taken out, but in most cases you want to avoid having a redundancy. 3.8's down, yeah. So you guys can kind of see as the tasks go up, so does the complexity of the network. These are more node networks where it's the arrow networks. The arrow is the actual task, so it's kind of like the path is the task. Node network is basically the same idea. It's just that the nodes are the tasks, and the arrows shown in between are those are more like the identifier paths. So again, I know this is a boring, bad subject. I'm trying to get through it as fast as I can. And I will let you know the type of questions that we want to be able to answer with this stuff. Basically, it's all kind of theoretical stuff to understand when we are doing schedules. All the different types of ways you can adjust a schedule. Sometimes you might not realize an impact because it's kind of locked in a bunch of interdependencies, and you don't on your bar graph. You didn't show that painting this drywall wall is related to stripping concrete forms, but in reality, because of all these interdependencies, yes, those two are related, and you change one, it affects everything down the line. So that's just kind of the basic stuff of these network diagrams. Here they at least start to add in actual construction looking activities, which helps for me. Lags and leads, again, same kind of situation. An activity can't start until a certain number of time after it finishes. So here we have an example of a lag and lead. So we're talking about concrete. So you form the concrete's a column. You put the steel rebar inside it. The mesh, the wire mesh and rebar will form a cage inside it to reinforce that column. Pour the concrete, wait for the concrete to set. Does anybody have any familiarity with pouring concrete?
I have a little bit, yeah.
Yeah. So you got some? Okay. So depending on what you're doing, you pour concrete, there's usually a cure time for that concrete. So when I go out and I pour my driveway, it might feel dry, 24 hours later, but it's not as strong as it can be. Like there's a cure time, which is usually, I think minimally it's, people are going to say 3 days. Sometimes it'll go up for 28 days, a cure time of 28 days to reach compressive strength of whatever 3,000 psi or whatever it is. That's the kind of thing we're talking about, where you can finish doing the concrete, but you still can't start. You can't erect the wood walls on a foundation, not just when you're done pouring the concrete, but you have to wait a certain number of time. That's kind of the thought here for lags and leads, not just a precedence, but a lag, an amount of time after where you have to wait. And how that's shown here is in, again, graphical form. Basically, you add a task, so even though it's only 2 tasks, put in the concrete, strip the forms, and here you're actually not stripping the forms until it cures. So when, in our schedule, we might just say place concrete, strip forms. In reality, we have to add another, that's kind of like your dummy task. It's not a real task. You're not doing anything, but it has to be there. So now you add in cure concrete. You've created a task, kind of. Again, not real, but definitely real, something you want to account for in your schedule. You don't do that, somebody cracks the concrete, then you hear about it. And if the concrete's in a necessary component, if it's holding up, steel, structural steel or something like that, they will actually do concrete core testing, where they come out and make sure, all right, I'm supposed to have 2,800 pound compressive strength concrete. They'll actually take cores in specific areas and to make sure it has the right, and they take that core back to a lab and they crush it. And that test is going to tell them, hey, your concrete didn't cure long enough, or you got a bad mix of concrete, but you're going to have to rip it out because that stuff ain't strong enough. And that does happen. I've had it happen, not a lot of times, but I've had it happen a couple times, even on a slab for, truck traffic or something like that. That's a big pain when you get, they poured it in wet weather or some weird thing, or they poured it when it was too cold out, and it affected the cure. And so you realize your mistake when you have to pay to rip out a whole big slab and do it again, because you didn't have that in your cost estimate. So just to reiterate that, it's not just tasks you have to worry about. It's material components and their characteristics. All that kind of stuff can get into your schedule. You want to make sure you don't schedule something and not take into account, those kind of tasks, or not tasks, but those kind of characteristics. And that's why you create something like a dummy task of curing. We're going to take a 5-minute break here so I can get some water, and we'll start back up at 8:06. Thanks. Share the screen. All right, back at it. So we went through that, all that kind of obscure network diagram looking stuff. And Susan, one of the things you asked about was, you know, why are they different? Why is that not right? The two tasks. This probably would have been a better way to describe it. You know, you can have other information associated with a task and a activity where it's not just the duration. You might have resources attributed to it, like man hours or cost, different things like that. That unique path is required because even though the time and the duration might be the same, you might have different resources associated with it where, yeah, but that takes, 32 man hours and this takes 60 man hours. And that's why there has to be a different path to be able to separately identify it, uniquely identify it, where it can't just be the task itself and the duration. Hopefully that should provide a little more information on a lot of these things. We talk about schedules. We're not just talking about schedules. There are often other resources involved in that and information that needs to go with that. So when we are talking about trying to differentiate and unique identifiers, all that kind of thing, there's other reasons to uniquely identify it instead of just critical path, time, time, length, duration of time, precedence. The critical path might need additional stuff in there for labor rates, all that kind of stuff. So, node diagrams, again, we talked about arrow diagrams. Now we have these node diagrams where instead of the task is actually the node and not the arrow. Very kind of similar information when we're talking about those. It's just a different way to do it. That kind of stuff, you can kind of see examples of connections, how to connect nodes and how to show parallel paths and all that kind of stuff. The recommendations for the proper node diagram when you're drawing them. Guess what? None of you guys are ever going to draw a node diagram after we get past this quiz. So I'll make sure we try to understand the concepts, but it's not something we worry too much about in practice. And there are some interesting points that you're conveying information with some of these points that I appreciate for trying to find ways to visually represent logic in ways that are not necessarily obvious. If you go through these drawing diagrams, they'll talk to you about it matters whether the connections come from the top or the bottom, the sides, the starts. When you're looking at these diagrams, there's a start side and a stop side or a finish side. So networks, they're not time scaled in general. Like when we were talking, I said earlier, we weren't showing the durations when we showed, A, B, C, D, E, and 10, 20, 30, 40, 50. Again, there's additional ways to put in that information. It's not time scaled, but it is sequential, is what I'm trying to say. Left to right, chronological order, just like you're reading a book. That's how a network diagram is put together. Those kind of, it's read the same way here. I was just trying to think if maybe in other languages where they read the other way, if their network diagrams work the other way. I don't know. One big thing is, and this is not only in network diagrams, this is in construction documents, all that kind of stuff. Try to avoid crossing lines. Crossing lines can be represented in certain ways. I did see up here where they had a jump. There's a kind of a representation of a jump over a line, but when you have crosses, it just makes it more confusing. There's a little bit better version of a jump crossing. The jump means that they're not touching each other, they're just crossing each other to get to, certain points. And that's the bulk of it for those. So, when you go through the activities for this, the activities are going to try to show, how to draw these network diagrams. These are some good examples of how you want to show them. Again, when you're showing any kind of network diagram, the big thing is about being unique, showing a unique path, and not necessarily the best looking design or anything like here. From A, say you had task A, B, and C here, you're trying to represent that. You want to show from A to B is a unique path, and A to C is a unique path. So you don't want to put common lines if you can, if it can be avoided, or it should always be avoided. But crossing, again, you got that jump thing. Those are the kind of things that will help you in any case. Just always trying to show unique paths and whatnot. Those are all just the tips for what you're trying to show. So the differences between them, honestly, when you're talking about visually, it's it's preferable. Those arrow networks are not used very often. The node networks are kind of more prevalent in network diagramming. But whenever you're trying to convey information, it's whatever is the simplest, whatever is the easiest way, and is the clearest way you can do it. So keep that in mind for when you are looking at these kind of things, or if you're looking at problems on the quizzes. You're worried about independence of uniqueness of paths and clarity of the drawing. Those are kind of the bigger points, instead of what you're trying to show in terms of dummy tasks and all that thing. It was more kind of representations. Again, this stuff was much bigger when computers weren't doing all that for us, but we still try to understand the logic behind these concepts as we move forward in scheduling and start assigning 5 different types of information to one task. You got to have kind of a way to reason through it and how to differentiate and convey the information you need to convey. Here, they bring it back here, kind of talking about the logic using bar graphs and precedence, how that's shown in bar graphs. You can see here it gets pretty ugly with bar graphs too. Here they're even showing time scaled logic diagram, meaning they're trying to, the length of the bar graph is representative of the length of time, the duration, the duration of the time. Sorry. Again, clarity is always going to be your best bet. Sometimes that's when you start breaking things up into subtasks or sub projects, subroutines. And you have a break line somewhere, connecting them, as opposed to trying to put it all in one spot. Might be clearer to separate it out into different, different parts of it and connect them a little more simply or visually by, you know, a connection point, or there might be 2 connection points, whatever, but subtasks and all that kind of thing. When you get into scheduling, you often run into lots of different paths. You might, you know, your end goal might be energized transformer, but you might have 3 different teams of people, a relay and protection team, a concrete guy, they're setting the pad and doing all that stuff. And the electricians are, you know, running the conduits and that. So you might have a schedule with lots of different tasks, lots of different teams working on different tasks or the same task. And all we're trying to do is to be able to logically in our heads think, you know, how do all those situations relate? Because, you know, if they're not visually connected or visually related on our schedule, you might not realize it, but when your concrete guy does something that changes his schedule, all of a sudden your relays can't be energized at the right time, and you know you have a blackout in some towns. So there's all these different dependencies and tools that they've developed to identify how to get through the visual representation and the logic path of all these different tasks and how they're created. Now we're going to be using software. A lot of the software has, you know, all this stuff is programmed into the software, and the thought behind it is the same, though you have to be aware of the different interdependencies, because if you're not, you'll miss a connection or miss something that, you know, might wrongly identify your critical path. You think it's one way and it's actually the other way. So I almost don't want to ask, but is there any questions on that? Specifically, I know it's a kind of obscure topic, and I tried to explain it to myself like 3 different times, and it's hard for me to even, and I know what I'm saying. So like I said, the important things will be for you to recognize kind of the concepts and not so much the really detailed parts of that. I did want to check in with you guys. So on software, has anyone here, so I know I have at least one person that's used Microsoft Project. Has anyone used Primavera or P6? I know I talked about it a little last time, but I can't remember if anybody had used it or not. Okay, I'm saying good, because I think so to sign up with Oracle, I think it is actually. I just was trying to find out if anybody might have already used it in any classes at Triton. Doesn't sound like it. So I do believe we'll have. There's a trial version of it. I could go ahead and try to get a education version. They don't have one, you know, readily available, but I don't want to spend too long, honestly, on one program, because I do want to. There's like 3 different programs we're going to do, so I wanted to. For Primavera, we'll do that first, and we'll do kind of a little project in Primavera. That'll be our first project. And we shouldn't need more than 30 days to mess with that. I'll try to keep it in our timing in the 2-week range, so we have a bit of fluff in that scheduling again, to make sure everybody can use it for the right length of time in that 30 days. So that will be helpful. So if I was to ask everybody here, let's create a project of renovation of your kitchen. What are some of the things we would have to put on that schedule? Some of the types of information that would have to be on that schedule.
Yes, this is Ayana. I would say demolition of the
Right.
previous, maybe cabinets or the tiles?
Yep, very good.
Deciding the outlay, dispatch.
I'm sorry, I missed that.
Deciding the design.
Design, correct, exactly. That's a big part of it, and it's, you know, that's definitely something if you don't work out beforehand and you get too far into it, you really can be in trouble. So very good, the design.
Ordering and receiving the new items to install.
Correct, yeah. So that's a big thing that we'll get into as we talk through some of these things. Your lead time on a lot of products. So for like kitchen cabinets, they can be easily 8 to 10 weeks, which sounds crazy, I know, but 8 to 10 weeks from when they take your down payment, honestly, I think it is. And so if your cabinets don't get there for 8 to 10 weeks, you really want to be pretty sure before anything else starting demolition. It would really be painful to start demolition and then realize you were going to have your new cabinets for 10 weeks. And until then, your kitchen is, you know, so fouled up that it's kind of unusable. That's why, you know, scheduling can help, you know, turn around the job as quickly and painlessly as you can. And, you know, lead times definitely, appliances, cabinets. You try to look for, when you're talking about lead times for stuff like that, you try to look for the long lead items, which are the items that take the longest to get, because you know, in most cases they are going to be involved in your critical path. What else you got for a kitchen? What else you got to kind of schedule for or plan for?
Any permitting necessary?
Wow, Susan's getting official on us here. Yes, permitting, building permit. Yeah, for something like that, for renovation of a kitchen, you would have to get a full building permit. Different towns have different levels of work you can do with before you can get before you need a permit. If you don't get a permit and then you bring a dumpster outside your house, all of a sudden the inspector's there and saying, why you got a dumpster outside your house? And they fine you, you know, a couple $100, or I'm not sure how much it is. I think it's $500 now. And they stop work. So that permit process can be a killer, you know, and it could be really long depending on where you're going through. And, you know, the precedence for that permit process is, somebody already mentioned, design. So you got to do your design, get that all squared away where you agree that, you know, you're showing the work you want, and then you have to take those drawings in to the permit office, the city, state permit office, wherever you're going, get it permitted. That could take, you know, Chicago, there was times it was taking 6 months to get through there. So all of these kind of things, you know, you talk about renovating the kitchen, you're thinking about cabinets and tile or paint. You know, there's all these parts of it that don't necessarily jump to mind, that are, you know, end up actually being the, you know, the critical path for your project. Also, you got your trays, your plumbing, for your sink, for your dishwasher, your gas piping for your oven, electric light fixtures, GFI outlets on your around your countertop, tile, flooring, what you're doing with flooring. If you're doing hardwood floors, sometimes you have to check the humidity level of basically you're supposed to take the hardwood material stored in your house for some amount of time and let it kind of come to humidity equilibrium with your house. So when you put it down, it doesn't all of a sudden suck in a bunch of moisture and, you know, buckle up and start popping. So there's all these, and that would be kind of like a lag, what we were just talking about. You know, you don't just get the material delivered. You got to wait for it to come to equilibrium with your house, and you know, you might have 3 weeks right there. So you know, we talk about a lot of this stuff in kind of obscure ways sometimes, and it's real academic. We're talking about nodes and arrows. When we get down to it, it is actual construction and actual tasks. It's just, you know, giving us a vocabulary to understand. When Susan told me there's a lag of 32 days, I understand what she means. I understand that, you know, there's some kind of time frame that we may not be doing anything, but we still have to wait for that time, and that's part of our critical path. That's pretty much it on that.
Hi, Pat. I'm sorry. I just have a question about
Yeah.
what you were just saying.
Yeah.
If something, they did have a lag time of like 32 days, so is it safe to say that that would be bumped up in the order of, let's say, chronological things, even though it's maybe one of the, you know, toward the end of the things to do, but would you, when charting it, would you put it, actually place it earlier or before other seeming earlier tasks?
And you might have an actual task, or you might create a dummy task for it, because say your, you know, cabinets, they literally are, you know, can be 8 to 10 weeks for delivery. Well, we're in, you know, we think of the cabinets. We want to install the cabinets. We don't want to wait. You know, we don't want to have our place all ripped up and we're waiting on cabinets. So you would create a task and call it ordering, cabinet order confirmation or something like that. Whatever the timeline kickoff is. Sometimes even for definitely for kitchen cabinets, there will be a shop drawing task, and they'll send over a drawing of, they come out to the house, measure all the walls and whatnot, and the cabinet guy will create a shop drawing, and he'll send it to you, the homeowner, or you, the contractor, and they'll say, confirm that my shop drawing looks correct. And when you do send it back to me, that might start the clock for your cabinet delivery. So you know, you can do it a couple different ways. You might break up, you know, shop drawings for cabinets, order of or fabrication of cabinets. Even though you're not doing anything, it's kind of a dummy task. It's still there. It has to be recognized. It is preceded by, you know, down payment of the cabinets. So yeah, you would definitely have some kind of indication early in the chronological order of it, because, you know, everything is going to kind of base off that too. So cool. Just want to check one thing. There was a exercise let's look at least the next path. And I don't know why they put this at chapter 4. They try to get all the visual, you know, graph making stuff out of the way. But the next chapter is the critical path method. That's, you know, like the methodology of, you know, pretty much every construction project is to identify the critical path and make sure you are maybe tracking or keeping special attention to that critical path. There's chapter 4 gives pretty good explanations, and it's a little bit more of a hands-on kind of meatier subject. It's easier to talk about. So we will, after you get your chapter 3 stuff done, you might want to take a quick look at chapter 4, read through it, and it's that, you know, is the kind of thing that comes up on a construction site every day. Critical path, long lead items are often part of the critical path, all that kind of information. It definitely can be useful, and it'll be something that, you know, you use going forward. So at least it's a little bit more of a, you know, understandable subject. I just want to check, there was a Networks chapter 3 exercises 18 and 21. Wanted to look at the chapters 8 or problems 18 to 21. So I don't think you might have had chapter 7. there is one of the, what are the homework? Yeah, number 17. Take a shot. The homework includes the first 6 questions for the chapter 3. Those are fairly easy, just kind of like 2 or 3 word answers. There is number 17 is the homework that, you know, I know that can get kind of big. Take a shot at doing it. And, you know, if you want, send me a picture of it, send me a text of it, and we can kind of look at it together. You're not gonna be doing critical path or I'm not gonna ask for any, on the quiz, I'm not gonna ask for a big giant network diagram of anything. Just take a crack at 17 for the homework, and, you know, just so it'll get you in the habit of trying to, you know, look at what you're looking for, the precedents, all the different activities, and it's kind of I'm not going to say fun, because obviously it's not fun, but it is an interesting exercise when you start getting into it and you start, you know, the logical thinking, how to show it and how to represent it visually. You definitely can kind of appreciate how complex stuff can get, and you know, how to represent it. It's an interesting exercise. I would say that 19. I'm going to so today is Wednesday. On Friday, I'm going to take a couple shots at doing the exercises 18 through 21, and I will send you those examples just so you guys, you know, can see how I approached it. I'll show you how many times I get it wrong when I'm doing it, because it's a network diagram. It actually is hard to get right on the first try. And then maybe if you want to use that for 17, just to create it, it takes you a minute to think through the logic of it and how big a space you need to write all this stuff down and all that kind of stuff. So I'm going to do one tomorrow, and I will send you all an email on Friday just to kind of show you how I organize it, and to kind of, I'll write down the logic I think through, because some of these examples in the book aren't exactly too descriptive on how they're organizing some of their thoughts. So my point was to try to show one and write down a couple steps that I would take that help me, at least, you know, in my head, organize how I'm creating it. That's all I got for chapter 3. I hate chapter 3. I was going through the syllabus and I read this and I was like, oh man, that is a dry chapter. So it's the driest chapter. You won't go through it again, I promise. Any questions?
Plug your PC in.
Yeah, right. 6%. It's going to end sooner or later. So.
Wait, so when is the homework for this chapter due?
So the homework for chapter, it's usually a week after the class. You know, you have 7 days. I would like to try to stay on top of it, just so I stay on top of the grading. I don't want to get too far back and forget stuff. So if you got, but stuff happens. If you got to turn something in late, just let me know. I'm not like trying to punish anybody because, you know, they got stuff going on, but we just try not to make a habit out of it and stay fairly current. All right. Okay. Sounds good. I will send over the examples on Friday, and I will be with that thing on Friday. You'll probably get the instructions for downloading the first software package, so we can mess around with it, kind of see what it's like. You know, maybe we'll do a little bit of it in class just to get used to using it. So, all right, everybody. Well, thank you for staying attentive through that, and I appreciate your time. Let me know if you have any questions or you need anything. I will talk to you Monday.
Okay, you know what, Pat? I just have one more question as well. Okay, for the no's that, like, some of them are, you know, go from to 20 to 30, and then some go to 25 or 35. So does it indicate, like, how do I determine if I'm going by multiples of 5 or going by 10s?
It's You know what? You could kind of make those anything, whether it's a
Okay,
10 or
so
a
that's
5. Like, it would just be like 100, and they'd be like 180 or something instead of 90 at the end. So they went by 5s. As you get a bigger and bigger, you break down the intervals between them from 10 to 5. Those are just identifying numbers. They're not necessarily like representing anything at this point. It's just like it's kind of a mathematical identifier in the node.
okay. So it does. Okay, got you.
Yeah, it doesn't mean too much right now. It's just trying to differentiate and, call it a number that's easy to track kind of thing.
Got you. Okay.
Sure. All right, everybody. Have a good night. Let me know if you have any questions, and thanks again. Bye-bye. Recording on.